A quick reminder, we defined our index with 3 key columns. It is keyed first on last name, primarily sorted by last name, then it is sorted by first name, and then by employee key. We have 3 included columns, which are middle name, emergency contact name, and status. Let's look at an example query, and I'm going to turn on actual execution plans using this button so that after I run my query, SQL Server will tell me how it ran the query. I'm going to run this query which says, find any rows you have where the last name is Zernek in the DIM employee table, and I want to know the first name, middle name, and last name. Those are all key columns. And then I also want the emergency contact name and the status, which are included columns. When I execute this query, I find there is one row. There's only one employee with this last name. If I look at my execution plan, I can see that I only needed to use my non-clustered index. I only have 2 indexes on the table. IX dim employee, this is my non-clustered index. I didn't have to go look in the clustered index of the table for anything at all. Everything I needed was in that non-clustered index, and I was able to do a seek. Well, what kind of seek did I do? If I hover over that and look at the tooltip for my operator, I can see that there is a seek predicate there. I did a seek predicate on the last name equals the operator I provided. My index has 3 key columns, and because I didn't give it all 3 in my query, but I did give it the first one, the thing that everything is primarily sorted by. So it said, well, I'll go find all those rows for you. I didn't have any additional criteria. I don't have any predicates other than my seek predicate. You'll see in the future, sometimes up here, we'll see something that says predicate without the word seek in front of it, and that is just not there. So we had a seek. Well, how many pages did it have to read for this? If I look at my properties, I'm going to right click and say properties, and I have my operator highlighted there. So I'm looking at the properties for my non-clustered index seek. What I'm going to do is expand where it says actual IO statistics here to say, okay, tell me a lot more about the IO that you did, the pages that you read. And it says for this non-clustered index seek, you only did 2 logical reads. You only had to read 2 pages. Now we know in theory from having examined this index that it's a 2-level index. There's a root page and then there's 4 pages in the leaf. So we hypothesized, we read the root page and then we did a seek to one of those leaf pages. That seems legit, but we can prove it with a trace. I am going to run an extended events trace using what's called a debug event. This is in the debug category of extended events, meaning this isn't something you would normally run. This can produce a large amount of data, and it's not something you'd run against production. This is just for, in my case, learning. I'm going to check out what my session ID is. I am session ID 52, and I'm going to plug it into this trace definition that says I want to create an extended event session looking at the buffer latch acquired event. I'm naming this buff latch acquired. I'm adding the event SQL Server latch acquired. These are latches on pages in memory that are data pages in my buffer pool for query. And when I already ran this query that pulled data into memory. When I run the query again, I'm going to need shared buffer latches on those pages to say, while I'm looking at these pages, don't let anyone else destroy them. Please protect them. So what we're going to trace is these buffer latches, and we're going to say, okay, what pages are you doing logical reads from that you're getting shared buffer latches on just for my session so that I don't get a bunch of gibberish from everyone else. I've set max dispatch latency to 3 seconds just to get it speedily. I am the only one using this little test instance running this debug session. I have created my trace, and I'm going to go ahead and start my event session, then rerun my query. I get the same execution plan, and just for fun, making sure, yes, once again, in the one that we traced, we did get 2 logical reads there. I'm going to stop the trace and let's look at the results in Object Explorer. I'm going into the Management folder, expanding out under Extended Event Sessions. It's always good to refresh. My trace has been stopped, but what I'm going to do is double click on the event file. I told this to write the results of the trace to a file on my file system. I'm going to open it up, and I have run this trace a few times before. So I'm going to sort the data descending by timestamp to see my most recent data. Here are the 2 latches that I'm looking for. And I even get, when I'm doing things like stopping the trace, I do have to get some buffer latches. So I'm looking here at the rows for my select statement in my session. And I have 2 pages that I read. I read page 158584. And let's take a look at that page first. I'm going to copy out the page ID. And now we'll go back, and what we're going to do is we're going to plug this into DBCC page. Looking at this page, what are you really page? Oh, indeed, just like we hypothesized, this is the root page for the DIM employees table that we were looking at, and it knows who the child pages were. So we're looking for the last name Zernak. Based on these guideposts here, CZ is after CH and it's before GR, so this should be on page 158552. If we look at 158552 in DBCC page and we scroll down, sure enough, here is the row that we're looking for. Our query wants to return not only these key columns, but also the included columns that are on the child page. And so if we look in our trace, sure enough, that was the second page that it read. It went to the root page and seeked to that one leaf page. It did not have to read other pages. Very, very cool that we can trace that and prove it. Let's look at a slightly more complicated example. What if we're trying to search on a column that isn't the leading column and we don't have last name in there? I'm looking, in this case, for the same row, but who knows, maybe there are other Pavels in there. I want to know information for all of my employees with the first name Pavel. All the rows are sorted first by last name. There could be Pavels anywhere in my child pages, so we can't seek on this index. The optimizer will look around and say, is there a great index for me that leads on first name? My clustered index on the table is keyed on employee key. That doesn't help. I can't seek on that to find the first name. But do I have a non-clustered index that's great for this? I don't. I have the clustered index that's keyed on employee key, and I have a non-clustered index that leads on last name but does have first name in there. And the non-clustered index has all these other columns as well. So SQL Server's smart. It says, I could scan that non-clustered index. I could also scan the clustered index, but it'll look at, okay, well, how many pages are in them? And it'll say, if I'm going to scan something, I'll pick the one that's smaller to scan. And that is why I didn't leave my fill factor at 1%, by the way, because that large page count would make it disfavor the index. So let's go ahead and start our trace again. And with our trace going, we are going to run this query looking for all rows with the first name Pavel. In fact, there's only one row, our familiar row. When we look at our execution plan, we see not an index seek, but an index scan. It said I had to scan the index. I couldn't find the data directly and efficiently by following the keys. Like, yes, this is a key column, but it's not the leading key column, and you don't have the leading key column in your predicate. This is the second one. But I could scan the index. When I look at the tooltip for this now, there is no seek predicate here at the bottom. I wasn't able to seek on something, but I do have a non-seek predicate. This is a filter that's been collapsed into the seek, where it's, okay, I've got to look at all these rows, and then for each one, I'm going to check. Are you Pavel? Are you Pavel? Is your first name Pavel? Is your first name Pavel? So that I can get the data out of there. How many logical reads did I do? Looking at our properties, in this case, we did 6 logical reads. Okay, well, 6 is an interesting number. Now, before we had to do 2, the root page and the leaf page. But you may recall that there are only 4 leaf pages for this index. Our root page plus our leaf pages equals 5 pages, so we did 6. Well, let's look at our trace and see what it captured. I'm going to stop our trace, and then let's go ahead and reopen our trace file and check out our latest results in there. We'll resort by the timestamp descending. And let's take a look at what we have here for our query. Things are a little different now for our query. We have, let's highlight this. I'm going to pop this up. This is the query that was looking for the first name. We have more pages listed here. So what I'm going to do is do a new vertical tab group so we can have this open at the same time as our other window, and we'll scroll over a little bit and look at some of these pages that it had to read. So the first page we have is page 187. We're going to go ahead and look at page 187. This is a page that, I am not sure from this information. This is a page who has child pages. Let's look at this page with dump style 2 to get more information about what this page is. When I run this with dump style 2, I get some information like from the metadata, what is the object ID? So this is object ID 74, sounding a lot like a system object, right? This is a system table named sys single object refs. These reads of system tables, and we can kind of tell from the low page numbers on like 97 there, if we have to pull some system pages, not all of those show up in the count of logical reads for our queries. Well, let's look at this one, page 93078. Let's copy that page ID and we'll paste that in. Let's first show that with dump style 3, just investigating what that page is. This looks like it's another system page. It doesn't look, if we look at some of the keys on here, this is kind of interesting. I think this is related to some of the management studio tools I had to show. We can just tell from the guideposts for what the child pages are, MS diagram pane 2. So this isn't related to our query either. When we get up here and we get into the 158s, this looks like the actual pages that's being counted in the 6 pages. I'm going to zoom a little, and we've got 1, 2, 3, 4, 5, 6 pages here that are related to our table. One of these pages, the root page, is actually listed twice. So let's go ahead and inspect those. I'm going to get this 158.584 value and copy it to my clipboard. And here it is. I have this here, or a similar value I had there already. And now let's go ahead and look at that page. Sure enough, if we look at that, that is the root page for our index that has the 4 child pages on it. So we can confirm, let's zoom in here. This is our root page of the index. And then here is, it went to the first page in the leaf. It then found the second page in the leaf and was following those pointers to scan through the leaf. We do have some additional buffer latches in here just from me having all of my tools open in Management Studio and using them in my session. So it is really fun, even if we have these extra pages in there, by using dump style 2 and dump style 3 and looking for the object ID and decoding it, we can figure out, hey, what was that system object that you had to go read? But we can tell that this scan, it went to the root page, then it went to one end of the index, and then it said, I'm going to go ahead and just scan through you using the pointers in there. That example was the query that was looking for first name, which is a key column, but not the first column in the key. We didn't provide a predicate for the first column in the key. What if we do something similar, but are searching in the status column? Status is an included column. It's not in the key at all. Can it use our index? It can use our index. If we execute this query, SQL Server will check and see, do I have a great index that leads on status where I can efficiently find this? We don't in this case. Employee key we aren't gonna be able to seek on that for status. And then this index, this smaller index, is a good choice though, because it has all the columns we need and it's smaller than the clustered index. So we can do a scan. If we look at the properties of that scan, we do not have a seek predicate, but we do have a predicate, otherwise known as a hidden filter. We'll look at every row and say, are you current? Are you current? Are you current? So SQL Server can, if we put predicates on those included columns, it can use them to help filter data, but we can't seek on included columns because they're simply tacked on and they write along in the leaf of the index and they don't impact the sorting at all. And we also don't have any guideposts for them in the upper levels of the index.